To understand that, one must first understand what is meant by a dimensionless number. A dimensionless number is a number which does not depend on what system of units you use, whether you refer it to centimeters or inches or any other units that you like. The dimensionless number will always be the same. An example of a dimensionless number provided by nature is the ratio of the mass of the proton to the mass of the electron. It doesn't matter whether you measure your mass in pounds or grams, you always get the same ratio. There's another dimensionless number which connects Planck's constant and the electronic charge. You get a number which is about 137, quite independent of your units. Now, when a dimensionless number like that turns up, a physicist thinks there must be some reason for it. Why it should be just 137 and not 256 or something quite different. And at present one cannot set up a satisfactory reason for it, but still people believe that with future developments a reason will be found. Now there's another dimensionless number which is of importance. If you have an electron and a proton, the electric force between them is inversely proportional to the square of the distance. The gravitational force is also inversely proportional to the square of the distance. The ratio of those two forces does not depend on the distance. That ratio gives you a dimensionless number. That number is extremely large, about 10 to the power of 39. Of course, it doesn't depend on what units you're using. It's a number that is provided by nature, and we should expect that theory would someday provide a reason for this number. How could you possibly hope to get an explanation for such a large number? Well, you might connect it with another large number, the age of the universe. The universe has an age because one observes that the spiral nebulae, most distant objects in the sky, are all receding from us with a velocity proportional to their distance, and that means that at a certain time in the past they were all extremely close to one another. The universe started quite small, or perhaps even as a mathematical point, and there was a big explosion, and these objects were shot out, and the ones that were shot out fastest are the ones that have gone the farthest from us. That explains the relationship, Hubble's relationship, that the velocity of recession is proportional to the distance. And from the connection between the velocity of recession and the distance, we get the age when this universe started off. It's called the Big Bang hypothesis. There's a definite age when the Big Bang occurred. The most recent observations give it to be about 18 billion years ago. Now you might use some atomic unit of time instead of years. Years is quite artificial, depending on our solar system. Take an atomic unit of time, express the age of the universe in this atomic unit. You again get a number about 10 to the 39. Roughly the same as the previous number. Now you might say this is a remarkable coincidence, but it's rather hard to believe that. One feels that there must be some connection between these very large numbers, a connection which we cannot explain at present, but which we will be able to explain in the future when we have a better knowledge both of atomic theory and of cosmology. Let us assume that these two numbers are connected. Then one of these numbers is not a constant. The age of the universe, of course, gets bigger and bigger as the universe gets older. So the other one must also be increasing in the same proportion. That means that the electric force, compared with the gravitational force, is not a constant, but is increasing proportionally to the age of the universe. The most convenient way of thinking of that is to use atomic units which make the electric force constant, and then refer to these atomic units, the gravitational force will be decreasing. The gravitational constant, usually denoted by G, when expressed in atomic units, is thus not a constant anymore, but is increasing inversely proportional to the age of the universe. One would like to check this result by observation, but the effect is very small. However, one can hope that with observations that will be made within the next few years, it will be possible to check whether G is really varying or not. If it is varying, then we have the problem of fitting in this varying G with our previous ideas of relativity. The ordinary Einstein theory demands that G shall be a constant. We have to modify it in a certain way. We don't want to abandon it altogether because it is so successful. And I have proposed a way of modifying it, which refers to 40 years ago, but he used different arguments from mine. His equations are in some respects similar to mine. In other respects there are differences, so that this theory of mine is essentially a different theory from Milne's, although based on some ideas which were first introduced by Milne, and one should give Milne the credit for having the insight of thinking that perhaps the gravitational constant is not really constant at all. Nobody else had questioned that previously. The amount of particles, elementary particles, protons and neutrons in the universe is about 10 to the 78, the square of the age of the universe. And it seems again one should say that that is not a coincidence. There's some reason behind it, and therefore the number of particles in the universe will be increasing proportionally to the square of the age of the universe. So that new matter must be continually created. There was previously a theory of continuous creation of matter called the steady-state cosmology, but this theory of mine is different from the steady-state cosmology, because the steady-state cosmology demands that G shall be a constant. Everything has to be steady, and in particular, G has to keep a steady value. Now, I want to have G varying, and I also want to have continuous creation. It's possible to combine those two ideas, and I've worked out some equations and models of the universe incorporating them. Because there would be a maximum size, this maximum size expressed in atomic units would give you a large number which does not vary with the time. Now, I want all large numbers to be connected with the age of the universe so that they will all increase as the universe gets older. And if your model gives you a large number of the order of 10 to the 39, which is constant, you must rule out that theory. It must go on expanding forever. It can't just turn around and contract like many people believe.